Okay, we're going to kind of switch gears here for a second, because I want to relate what we're about to do with what you have done in college algebra and intermediate algebra. So you don't need to write this down, just kind of pay attention. This was along the lines of the getting ready assignments that y'all did. An example here. Let's look at this function f of x of 2x plus 1, and I have another function g of x of 3x squared. If I wanted to find a composition of functions, that means I'm putting one function into the other function. Our textbook in college algebra used this symbol right here, f of g of x, and we also said that that meant f of g of x. I'm putting the g function into the f function. I'm going to take this whole thing and put it in place of this x. So I have 2 times 3x squared plus 1, and that's 6x squared plus 1. So y'all remember function composition, right? Another thing that we sort of touched on in college algebra was looking at inverses. So I could say that this is y equals 3x plus 4. This is my original equation. If I wanted to find the inverse of this function, I switch the x and y and then solve for y. So I get x minus 4 divided by 3 equals y, and that is the inverse function, or f negative 1, with what looks like an exponent negative 1. And I know that, and this is where I think our college textbook, or at least our course that we do in college algebra, is a little bit lacking. If we found f of f inverse of x, or if I found f inverse of f of x, either way, I am going to get x if my domain is restricted. Is that, y'all remember that f inverse when you put 1 in? I mean, that's what happens when you do inverses. They're opposites of each other. They sort of cancel each other out. So if I put this expression or equation right here in place of this x in my original function, I get out x. If I put this and this x right here, I end up solving and I get out x. And again, that works when your domains are restricted. And there was a problem that we did in intermediate algebra where we weren't really talking about functions so much as we were just talking about simplifying radical expressions. And I wanted to look at simplifying this. And I couldn't just say that the square and square root were inverses and canceled out and gave me x. The answer here was the absolute value of x. I think we did 1 or 2 problems like that in intermediate algebra, and then we never saw it again for the rest of the chapter, because everything after that, the direction said, okay, assume that these are positive numbers. And we can see an example of this. If I have -5 squared and then I take the square root, I cannot just cancel this out and say that the answer is -5. You have to follow your order of operations and have -5 squared is 25, and then the square root of 25 is 5, right? So inverses do not always just cancel each other out and give you what you started with unless you're in the right domain. And that's kind of where we're picking up with inverse trig functions as well, that we cannot just always cancel out inverse trig functions when we compose them, because we know that when we're looking at inverse trig functions, we have a restricted domain. One other thing I want to talk about here, give an example of before we go on to composing trig functions. Let's say I have f of x equals 2x and g of x equals x minus 3. And again, this is something that we did in intermediate algebra and college algebra. You don't need to really write this down. If I want to find f of g of, let me say that again, f of g of 7, then what that means is I want to put 7 into the g function. Whatever I get out, I'm going to put into the f function. And I always like to do these problems as a mapping. I'm going to put 7 into the g function, and then whatever I get out is going to go into the f function. So I find g of 7, which is going to be 7 minus 3, and that's 4. So now 4 is the output of the g function. It's now going to become the input of my f function. So I'm going to find f of 4. So put 4 in here. I've got 2 times 4, and that's 8. So my final output is 8. Okay. So when we're given a composed function like this, we start with this inside part, evaluate that, and then whatever answer we get out, we put into the next function. And that is going to lead us into composing trig functions.